They are the all-purpose weapons of the military. Drones are the eyes in the sky. They make the battlefield transparent. By doing reconnaissance, drones take aim at their target and can attack. Drones are becoming intelligent, artificially intelligent, and therefore autonomous. After gunpowder and nuclear weapons, are drones the next revolution in military technology? Drones are changing warfare.
And those who do not recognize us will fall behind.
On the front line in Ukraine, a German vector reconnaissance drone is being prepared. It's ready for takeoff in just 2 minutes. From his laptop, the pilot guides it to its mission, which leads it far ahead towards enemy lines. Hundreds of vector drones are now in use in Ukraine.
The vector drone is able to stay airborne for over 3 hours. The operational altitude is greater than 1,000 meters. It is not visible, not audible to the own operator, not even to the enemy forces. It can fly up to 50 kilometers into enemy territory. In other words, far out of sight of the person controlling the drone, as you can imagine. And once there, it delivers the results it needs to be effective.
Sven Cook is Managing Director of Quantum Systems. The Bavarian company, which started out as a civilian supplier, is now also a sought-after partner for the military worldwide. They're building high-performance flying computers here. They are designed to spy and deliver top-quality images in real time and at all times. Because the Vector can find its targets even without GPS, including at night and in poor visibility. To enable their drone to navigate entirely without GPS signals, the software team has developed an AI-supported sensor system.
If there really is closed cloud cover, I don't have any navigation options at that moment. But because our autopilot has a gyro compass system, it can find its way for a limited time until there's a break in the cloud cover or we've flown lower to get below the clouds. And then I can use this solution to immediately find my way back to where I am in the world. I emerge from the clouds and identify these 5 items on the ground, check my maps to see where they are, and then I know where I am again.
Receptor AI is the name of the AI upgrade that not only guides the drone to the target, but also recognizes whether it's the right one. The AI is trained to distinguish between soldiers and vehicles based on uniforms and vehicle types. The drone can pursue its target autonomously without the drone operator having to control it. He can now take a closer look at the battlefield on the monitor.
Here, a normal reconnaissance flight is carried out at night, and the operator is basically looking for things on the ground. Conspicuous features, perhaps troop concentrations. What's also very interesting is that even though the city is deserted, every chimney is looked at to see if it's emitting heat, because that tells you if someone's there. These aerial reconnaissance teams have a lot of tricks and expertise for finding out the information they need.
The reconnaissance drone determines the coordinates of the target and transmits them to the artillery, a prerequisite for a precise attack. The command is given by a human being. Even if they do not carry explosive charges themselves, reconnaissance drones are feared weapons. They can detect almost everything. Nothing remains unobserved on the battlefield.
The reconnaissance drones provide the so-called transparent battlefield on the first level, the eyes over the battlefield. Then, of course, the AI and the software elements that we have also integrated into our system are also used to make assessments. Are they enemy forces? Are they our own forces? And how can I react to them now? Are they too far away? Are they too close to take effective action? What means can I perhaps use? And this actually happens downstream in the so-called sensor data fusion Ukraine via battle management systems. In other words, software systems that bundle all this information and then interpret it.
At the turn of the millennium, drones were still a long way from intelligent software systems like these. Even the US Predator. Nevertheless, the Predator will make military history after the attacks of September 11, 2001. For the first time, unmanned aircraft are in continuous use in the fight against terror. What's more, the Predator, with its 24-hour scouting capabilities, is armed. It was the beginning of the age of combat drones and of debates about unmanned warfare from the sky, waged by crews thousands of kilometers away.
These wars on terror in particular have shown what drones can do. And it was seen worldwide that the ability to track targets, to stay in the air for a long time, and to do so at very low cost, and being able to attack from the air are incredible advantages. And this has given drone development a huge boost. We've seen an upward trend ever since.
Security expert Ulrike Franke has been following the rise of unmanned fighters and their impact for many years now. They are systems with the potential for complete autonomy. Systems that will be difference makers in the future. Weapons for any occasion. Reconnaissance drones monitor the front and spy on enemy positions. Increasing numbers can also be armed. Classic combat drones attack. They carry explosive devices. Their attacks are carried out with extreme precision. Kamikaze drones blow up their target and themselves. Loitering munition lurks above the target and waits until just the right moment. Drones can fly alone or in groups. Some take off from flying platforms. They maneuver through buildings. They track people. FPV, or first-person view drones, are controlled by pilots wearing VR goggles. They experience the attack from the drone's perspective. All over the world, drones are highly sought-after weapons systems that are being developed at a rapid pace.
It's no longer the case, as it was in the 2000s, that the USA and Israel have a near monopoly in this area. Today, many countries can produce drones. Some are better than others, and development varies. But in war, it's often the case that good enough is also okay.
During the war in Ukraine, Russian attackers terrorized the cities for a long time with single-use drones from Iran. The Shahed 136 can fly 2,000 kilometers and has 3 times the explosive power of a normal artillery shell. Russia is now reproducing it as the Geran 21 and sending it into battle again and again. The Kremlin was slow to recognize the advantages of the cheap unmanned systems. But afterwards, the then Russian Defense Minister Shoigu had production ramped up. Volume matters. 48 new drone factories are to be built by 2030. For a long time, the Lancet was particularly effective and therefore particularly feared by Ukrainian defenders. It pursues its target and is considered to be a tank killer.
The Lancet is a Russian drone that the Ukrainians are finding relatively difficult to intercept. The Shahed 136 is a system which the Ukrainians are now able to intercept with a very high success rate. That is one reason why Russia is now using them in a very large number. So instead of repeatedly sending a single Shahed, which will then be shot down 80 or 90% of the time, they're sending 100 or 200 of them. And Ukraine is sometimes simply unable to intercept them all due to the sheer numbers. So the Russians are able to get through again.
China is also getting involved, supporting Russia with components and entire drone systems. A film by Chinese state television shows the importance of high-tech aircraft, especially when they have artificial intelligence. China has been modernizing its military for years, and it's keeping a close eye on developments in Ukraine.
We are definitely witnessing a new arms race between drone manufacturers in the various fields. Cheap drones for mass deployment, more expensive and much more sophisticated drones in the field of reconnaissance, but also an arms race between drone manufacturers and drone defense manufacturers. Of course, you can only see what Russia and China are developing from what you recover in terms of drones that have been shot down, for example. We don't know exactly what they are developing and what they will be working on over the next few years. I wouldn't underestimate China in particular in this case, because they are very good at adapting things. And then the question is, who will develop them faster?
Christian Hübenthal publishes a security policy newsletter. This rapid development is no longer limited to the sky, he says. Now that they have conquered the skies, drones are advancing into all dimensions as all-purpose weapons. The Manta Ray underwater drone is a giant unmanned submarine that glides through the sea like a ray. According to the manufacturer, it's designed to carry out missions where humans cannot go, at extreme depths with almost infinite range. The Ukrainians have hit the Russian Black Sea Fleet hard with surface drones they developed themselves. The maneuverable remote-controlled boats attacking groups. They're said to cost less than 200,000 euros and can destroy warships worth up to 60 million euros. Ground-based drones. These also include robot dogs. In Ukraine, they transport ammunition through danger zones, scout, and detect mines. The remote-controlled four-legged units are already in service with numerous armies. For civilians, they're a sight that takes some getting used to.
Of course, seeing it is also strange because it's new. I think that cars also used to alienate people and that airplanes alienated people. I think that this is a phenomenon that will pass, and the boundary between gimmickry and realistic field of applications is very thin, or even non-existent in research and development. So you try something out and realize that it works very well in this or that area. We expand it, or we just add to the capabilities of something that already exists.
To travel alone to places where people are at risk. Gerion from Munich-based startup Ox Robotics can transport heavy loads, or it can be the vanguard and conduct reconnaissance. It can travel up to 4 kilometers away from the human controlling it remotely. With the help of AI and pre-programmed target coordinates, it can also navigate completely autonomously. However, the development of autonomous unmanned systems on the ground is much more complicated than in the air. This is because there are significantly more obstacles on the ground.
It's muddy on site, the terrain is difficult, people are under pressure. High-tech doesn't always work. That means you have to find this compromise between it's high-tech, it's software-enabled, it's AI-capable. The new technologies are there and can be used, but it's still so robust that I can operate it with gloves on in the mud, in adverse conditions, in the cold, in the damp.
Most battles take place on the ground. However, the development of unmanned ground drones is only slowly picking up speed. Intelligent robots can help here, either by taking the place of a soldier on the battlefield or by providing the soldier with support up close. The camera and the AI model create the connection.
You can now see from the robot's green status light that the robot has logged onto me, has recognized me as a person, and is now being operated by me, that it's following me. This is particularly important in situations where the soldier has to continue to focus on his primary task. For example, they have to aim their weapon, carry something, operate something else, but still need a system to follow them, for example, to transport wounded soldiers or materials. So what we're trying to do with Autonomy is to get rid of the remote control. Because the soldier can't concentrate on a remote control and on their weapon. They need to keep their hands free and require a system that can simply follow them and work with them.
Mark Wiedfeldt was a soldier himself for many years and knows that in an emergency, every bit of support counts, even that of machines. When the tracking algorithm starts, the robot recognizes the user's movements and follows them. The more independently Gerion moves around the terrain, the better. Cameras and LiDAR scanners map the terrain, while the AI-supported software analyzes and develops solution scenarios.
The robot knows where it should go and does so autonomously. It carries out a real-time traversability analysis of the terrain in front of it. It recognizes obstacles, identifies possible detours around these obstacles, and ultimately reaches its destination without human intervention. The robot is never alone on the battlefield. That means you are never alone on the battlefield. Your own forces are on the move, the enemy appears, there are civilians on the move. Where artificial intelligence comes in is in evaluating all these things, bringing the sensor output together to form an overall picture that can be understood.
The robot was only programmed at the beginning. What obstacles are there and what solutions? With this basic knowledge and AI, the system learns on its own. With different modules and a few simple steps, it becomes an autonomous all-rounder. A stretcher to transport the wounded. A camera or radar to conduct patrols.
What we're doing with the systems there is minimizing this human movement and this movement of large equipment. Nobody has to go and fetch water. Nobody has to risk their life to go and fetch ammunition from trench line 1 to trench line 2, because in many cases unmanned ground systems can do this fully autonomously. And that's how we protect people and protect large equipment. These systems are a complement to the soldier, a complement to the main battle tank, the truck, the jeep.
The Gerion systems are battle-tested. Its developers have also learned a lot from the war in Ukraine. High tech is only of value if it can also be used in combat.
The development of military technology always advances by leaps and bounds when there's a war. As tragic as the situation is for Ukraine, it must be said that it creates an above-average increase in knowledge in a very short space of time for the military, including for the West.
Ukraine as a test laboratory. In less than 2 years, warfare here has changed completely. Devastated cities, the dead and wounded are still part of the war. But tanks and fighter planes have lost their dominance since the Ukrainians discovered the drone as a weapon.
We don't have to fool ourselves. We know that in Ukraine many systems are lacking everywhere you look. But drones, especially civilian drones, are still easy to buy. It's not always easy in Ukraine. But at the end of the day, hundreds of thousands of civilian drones can be procured and then converted, modified, and so on. So availability is a key factor. And drones are sometimes used in situations where you would perhaps rather have other military equipment. An anti-tank weapon, for example. But you have the drones, and you use them, and it works.
Drone units form a separate branch of the Ukrainian army, a novelty. Unexpectedly, the soldiers were able to stop the Russian advance in the first year of the war, mainly thanks to mass-produced armaments. The units are often armed with short-range drones. They therefore have to operate close to the enemy positions and can quickly find themselves targeted. The war of drones has made the front transparent.
A drone with night vision and a thermal imaging camera is flying over us. This means that all our movements are visible. We're not yet a priority target, but if it spots us because it notices that we're flying our drone, then things will look different.
Within a few minutes, the soldiers attach the explosive charges. This drone can carry 4 of them, each weighing 3 kilos. Before the war, it sprayed fields with pesticides. Now, it helps with national defense. The drone has an infrared camera and can find its targets even in the dark. Portable Starlink antennas provide stable internet and transmit the recordings in real time to the pilots on the Ukrainian side of the front. They control the drone via tablet and search for targets, Russian positions.
We can destroy some buildings with infantry, so we then destroy something just to destroy. If we see some movement inside of enemy movement here, we try to destroy the position. We can destroy the trenches. We can destroy any vehicles like tanks also. So actually any kind, because this type of drone can take maybe 10-15 kilometers, depends on on distance.
The pilot gives the order to attack on the tablet. Drones cannot yet decide an entire war, but they can decide individual battles. The Ukraine war offers the blueprint.
This is clearly the first war in which drones have played such an important role, where both sides have hundreds of thousands, if not millions of drone systems in use, and where you really have to say, I couldn't imagine the defense of Ukraine without drones. So the relevance, the number, the way in which they're being used, that really is new and unique. And in that sense, it really does mark a watershed.
It's also a watershed for Germany. Lieutenant Colonel Marcel and Captain David take a look at the German Heron TP, the Air Force's first drone that can not only be used for reconnaissance, but can also be armed. It's part of the NATO Tiger Meet exercise. International Air Force units practice cooperation in Jagel, Schleswig-Holstein. For the first time, the fighter jets are being joined by a drone. The Heron TP itself is as big as an aircraft. Its wingspan alone is 26 meters. It does not yet carry any weapons. First, the soldiers must familiarize themselves with its operation. How do you control this giant aircraft when you're not sitting in the cockpit, but in a container on the ground?
The biggest difference is that this cockpit does not leave the ground. It remains stationary. Otherwise, it is very similar. All the displays that you normally would have in the cockpit of a real airplane are also here. They are displayed on screens and nothing else moves.
The German Heron TP is the first unmanned system in the world allowed to take part in general air traffic. This is a special challenge for the pilots. They're specially trained and have a license to fly manned and unmanned systems. Much is programmed. Nevertheless, the soldiers must remain in control and be ready to intervene at any time.
You have to be focused. It's true a lot of the flying is automated. You can imagine it like an autopilot. It's the same with a real airplane. Nevertheless, you still have to stay alert and make sure that the autopilot does what it's supposed to do. You can't just lean back and close your eyes, or at least you shouldn't.
While we're flying, me and my weapons system operator next to me are also looking at the images we're generating or at the things we're seeing.
The soldiers of the Aerial Photography Squadron analyzed the drone images. They're of a quality that was unknown from its predecessor, the Heron 1. The 5 sensors and cameras include an SAR sensor, whose microwave radiation can even penetrate cloud cover. There's hardly anything at Jagel Airfield that the drone misses.
From what height did we take the pictures?
So the drone's currently flying at 2,800 meters, and the distance to the target is 4,400 meters. It's quite a lot of footage we're getting here at the moment.
So the difference to its predecessor is increasingly clear.
Yes, totally. You can now recognize people, hairstyles, everything. Here it jumps into infrared again. You can even see when people are moving under trees. You can see into the shadows perfectly, so you no longer have any blind spots.
You can also see that the operator's getting better. The camera doesn't shake that much.
In this new era, the Bundeswehr is equipping itself not only with weapons, but also with sensor technology to create a transparent battlefield.
You have to imagine it like this. With the old sensors, we were roughly at the level of analog television. Now, with the new sensor technology, we have finally arrived at full HD. As a result, we still can't see any details in the face, but we can really say he's holding a cell phone, lighting a cigarette, for example. Or depending on whether comprehensive characteristics are known to a certain extent, if everything is really good, we might even be able to say which person this really is.
At the International Aerospace Exhibition in Berlin, the ILA, the defense industry is more present than ever before. Here too, the focus is on drones and drone defense. Systems like the Skyranger from Rheinmetall are designed to deal with unmanned attackers that appear in swarms. A challenge because the larger the swarm, the greater the chance of breaking through the enemy's defenses. The Skyranger detects them with radar and other sensor systems. Algorithms compile the sensor data and classify the targets as threats. The cannon can fire up to 4 kilometers, 1,250 times per minute. The airburst ammunition shatters and knocks the drones out of the sky in seconds. Drone attacks are also repelled by electronic warfare. Enemy transmitters jam the GPS signals that are supposed to guide the drone to its target, so that it goes off course. Spoofing is another method. On several occasions, Ukrainian defenders have succeeded in hijacking the unmanned attackers, overriding their GPS target data and sending them to Russia or Belarus. And supposedly, old methods of defense are also being rediscovered.
For example, a Russian drone was found in Ukraine that had a 9-meter-long cable attached to it. A cable is not a radio signal. This used to be the case with light anti-tank weapons, such as the Milan. They were able to maintain control by having a wire attached to the back. This is actually an old system and is now being rediscovered, so to speak, to avoid electronic warfare, at least temporarily. Whether this is such an effective system with a maximum range of just a few kilometers, whether it is used in the future remains to be seen, but at the present time, it is one way of dealing with electronic warfare.
Efforts are already underway to overcome drone defenses. The AI team at Quantum Systems in Munich has developed a special method to protect its drones from enemy jamming. If a drone loses its connection to GPS due to interference and can no longer transmit its own position to the pilot, an automatic search process is triggered. The AI compares the images from the drone camera with stored maps from Google Maps. If there are sufficient matches, the drone can navigate safely again. New challenges are constantly emerging.
We fly a lot of missions at night. This means that we can't only rely on images, let's say color images, electro-optical images, but we also fly a lot, as you've seen here in the background, on the basis of infrared data. And that's an additional technical hurdle for us to implement a visual navigation, for example.
The company also has a branch in Ukraine. It builds, repairs, and develops close to the front line, almost in real time, because feedback from drone units is received almost daily. Solutions are then sought together with colleagues in Munich.
Ich würde sagen, es ist ein ständiges Katz-und-Maus-Spiel. Also wir sehen, dass wir eine Zeit lang
I'd say it's a constant game of cat and mouse. We see that for a while we can deal with these situations better. On the other hand, it's also clear that the opposing side is also constantly working on electronic warfare. In other words, it's a constant back and forth, and there will never be a situation where one side has the constant upper hand. But we have to continuously react and improve the methods we can implement in order to simply stay on top of things and ultimately be able to react to this situation.
The battlefield fuels development. It's a new kind of race because drones, the key technology of the future, are not developed over the course of years, but are instead updated in a matter of days. The drone race. It's also taking place at the International Aerospace Exhibition. The ILA is hosting the model of a drone that is set to become the largest in Europe, the Eurodrone. 2 engines, 16 meters long, with a 28-meter wingspan. 4 countries are building it: Italy, France, Spain, and Germany. The German aviation group Airbus is leading the ambitious project.
The Eurodrone will be a system unlike anything currently on the market. The drone will have a flight time of over 40 hours. And even with a substantial payload, we will still be able to stay airborne for over 20 hours.
The Eurodrone is designed to carry a payload of more than 2 tons, to drop rescue platforms and other material, fire-guided missiles, and deliver surveillance data.
What we see here now is our reconnaissance payload. For one thing, there is a reconnaissance radar, a search radar with which we can conduct radar reconnaissance. And if we then look under the nose here at the front, we have an integrated electro-optical payload with which we can also take pictures and conduct further reconnaissance.
The Eurodrone is intended to deliver images from a distance of 20 kilometers and replace the German Heron TP as an unmanned, long-range weapon-capable system starting in 2030. With a price tag in the billions of euros, it's not suitable for direct frontline use.
Aircraft and drones in this size class in particular, which are of considerable value, are not intended to be flown directly into contested areas, but remain in the background. And by being able at long distances and at long range to generate data, ensure this situational awareness that I need in order to be able to clearly recognize the situation.
The fighter jet demonstrations are the spectator attraction at the ILA. But in the future, their pilots will also be working with unmanned aircraft. Fighter jets like the Eurofighter often have the support of other aircraft, wingmen, during missions. This might be what the future looks like, almost as big as the jet itself, but without pilots on board.
Nowadays, pilots talk to their wingmen digitally via networks and give instructions. And for the pilot, it's ultimately almost irrelevant whether the receiver is a manned or unmanned aircraft. That means, of course, that it's a challenge to get the technology right. But in terms of cooperation, it's not a revolution. We're simply replacing the pilot of the wingman aircraft.
Critical decisions, such as the order to shoot, are only made by the pilot in the cockpit of the jet. He retains control of the wingman, even if the drone navigates independently and carries out its missions largely autonomously.
There are many drones. The wingman's capabilities put it in the same class as a fighter aircraft. So it's an unmanned combat aircraft. This means it has little in common with many of the drones that we're seeing a lot of in Ukraine right now, in the 100-kilo drone range. In other words, the wingman will have capabilities that are complementary to those of a fighter aircraft. It plays in the Champions League of drones, if you like, so its capabilities resemble those of a fighter aircraft and not those of drones that are for a specific minor purpose, which are more like drones that you can buy in a retail store. There's a very wide range in between.
Pilots benefit from the fact that they can hand over risky tasks to the wingman. This remote relationship between man and machine is a major step towards the networked defense systems of the future.
The combination of manned and unmanned systems, also known as manned-unmanned teaming or crewed-uncrewed teaming, is a huge area because it is assumed that this will hopefully give us the best of both worlds. In other words, the capabilities, the possibilities of unmanned systems, combined with the decision-making ability and responsibility that humans can then take on, that will give us the best of both worlds.
The Bundeswehr is practicing the interaction of manned and unmanned aircraft for the first time at the NATO Tiger meeting. The German Heron TP is still somewhat of a novelty here, but 4 more drones will soon be added. People here do not believe that the drones will replace the daredevils in their aircraft.
Yes, the drone will never be the sole means of choice. It will never completely replace combat aircraft, but it will always work well in conjunction with manned aircraft. And that is exactly what we are now testing with the German Heron TP here at Jagel, in action together with manned aircraft, including during the exercise here at NATO Tiger Meet 24.
This is where the Air Force demonstrates its power. In an emergency, the pilots have to be able to rely on each other, on their aircraft, and on themselves. Reconnaissance, support, and air combat. These are their tasks. Those who control the airspace can also control the battlefield on the ground. The demands on the pilots are enormous. They fly and fight at supersonic speeds over long distances. The German Heron TP is designed to relieve the pilots of their workload and is gradually being integrated into their highly dynamic working environment. This exercise is not yet about interaction in the air. Here, the jet pilots are first learning how to work with the data that the Heron collects.
It is not fully integrated into the exercise, but it is part of the exercise and also provides sensor data for our further tactical design of the exercise. And there are, of course, certain lessons identified and lessons learned, which we then ultimately use in the further planning and deployment of unmanned systems of this class.
It took 10 years for the decision to acquire a weaponized drone to be made. In the future, air combat will not be possible without them. A complex weapon system will then guarantee defense capability. Germany, Spain, and France are working on this together. In the future, combat air system, manned and unmanned components will be networked with each other. 6th-generation combat aircraft with satellites and autonomous drones, the remote carriers. The centerpiece will be the combat cloud that connects everything and evaluates all data, ideally including that of the manned and unmanned systems in the water and on the ground.
So integration is a big issue. In general, you can say that a weapon system is only really useful when it can be used in concert with others. So a weapon system doesn't just arrive on the battlefield and do its own thing, but should be connected to other systems. And we can see this very clearly in Ukraine, for example. Drones have the greatest impact when they are directly integrated into the artillery system. The drone provides information, and the artillery system attacks. And it's similar with the other unmanned systems at sea or on the ground.
Startups are also rapidly advancing networking. Here, the Vector aerial drone uses the ground drone as a launch pad. The ground drone can also transport the Vector and supply it with additional power. Even vehicles that have been in use for a long time can be networked. The Enoch patrol vehicle no longer needs a driver since the operating system from ARX Robotics was installed. It's the same system that allows the ground robot Gereon to drive autonomously. Gereon and Enoch thus become Gerenok. We don't always need new tanks or transporters that cost millions and often take years to produce.
The vehicle can be driven autonomously. It can be operated remotely. Here we can see a pedal and steering wheel robot at the steering wheel and pedals that can replace the driver. So a classic use case would be a three-man team that has a security mission. They can sit here and then bring the vehicle to the flank, for example, to carry out surveillance there, so that these three are not surprised by the enemy on the flank during their security mission.
In an emergency, the team can concentrate on its mission. The AI makes a driver superfluous. The unmanned vehicle Gerenok becomes the fourth man, the wingman. Just like the ground robot, which can transport injured people across the terrain without human assistance and return them to their own unit.
What we're seeing here is the integration, modernization, and networking of all systems on the battlefield. The system here is being made software-capable, AI-capable, and integrated with the other systems. And this will give us the future. That's the prerequisite for successfully carrying out multi-domain operations, the modernizing of our existing fleets. What we've done with this vehicle here, we can do with any other vehicle. We can bring the NATO fleet into the next era.
It will be the age of unmanned systems. It will not only be individual drones equipped with artificial intelligence acting autonomously, but rather as many drones as possible, together and simultaneously. Swarm intelligence will make the difference.
Most armed forces are in agreement that a few developments constitute somewhat the goal for the future. These are swarms, systems that really cooperate with each other, where hundreds or thousands of individual units function as one and can then launch joint attacks.
Back in 2016, American Air Force pilots dropped 103 mini-drones from fighter jets to test their swarm capabilities. They are barely recognizable in the pictures. The light 300-gram aircraft came from a 3D printer. Their flight paths were not pre-programmed. The drones had to organize themselves in different formations. To do this, they had to communicate with each other, keep exchanging their coordinates, and function together as one system. It worked, thanks to artificial intelligence. Five years later, a swarm overcame even greater challenges in a test conducted by the US Department of Defense. The drones completed an obstacle course. They found their way between buildings and high-voltage power lines without any accidents. And they worked together with unmanned systems on the ground. Over 100 drones were networked together. A single person could control them all. Chinese scientists have now developed drones whose cameras and ultra-wideband sensors can recognize every tree branch. Each drone maneuvers independently through the bamboo forest, and yet the swarm stays together. Swarm intelligence can track down and rescue people in inaccessible disaster areas. In wars, it can become a weapon.
You can also imagine that a swarm of drones can fly waves of attacks, for example. So you attack once, then you've made a hole in a bunker. Then the next drones come and fly in and blow up the next hole. Such attacks are conceivable. Flying minefields are another possibility. So you basically say, this is the area that the swarms of drones are supposed to cover. Then you fly the drones in this area and say it's now off limits. Nothing is allowed to fly in or run in or swim in, and we'll shoot down anything that does so. So it's like a temporary minefield in the air that can then cordon off an area.
On NATO's eastern flank, soldiers with tanks and other heavy equipment regularly rehearse what they would do in the event of an attack. There are already plans for a drone wall against Russia that would extend from Norway to Poland. Drones could help to monitor the border sections by independently sharing situation images and other information with each other.
The drone wall project in the Baltic states is at an early stage, but I think it shows the direction we are heading in. Monitoring borders with drones, for example. This is being done more and more, and it makes a lot of sense to take advantage of drones' endurance and reduced vulnerability to make regular patrol flights.
Lots of drones, intelligent drones, high volume and AI. Both are necessary to ensure equality of arms so that deterrence and defense can work. Having supplied Ukraine with reconnaissance drones, Quantum Systems knows how crucial it is to be able to ramp up production reliably and quickly at any time.
It's not just the complexity of drones that poses a challenge for every drone company in the world, but also scalability. We don't just produce hundreds of drones, we produce thousands a year. And I think that is also something that makes us very, very different, and something that will be needed much, much more in the future. Because in addition to the timely provision of drones, of the quality that we see here, scalability is also very important.
But if more and more drones are used in the future, making increasingly autonomous decisions, will it be just robots fighting robots? What role will remain for people?
People are increasingly becoming users. However, humans will remain the linchpin of every military mission. No higher decision-making authority will be transferred to machines. Nevertheless, it must be understood, soldiers are citizens in uniform. They're parents. They're someone's children. They're part of our society, and it's irresponsible as a democratic society not to equip these people, these soldiers, with the best possible material so that they can fulfill their mission and so that they suffer as little as possible or come to no harm at all.
It's difficult to predict which scenarios will only be unmanned and which will involve such teamwork. Normally, however, there will always be a collaboration between people and machines. Pure robot warfare is still a long way off.
Autonomous drones and robots can save lives in war and destroy lives. War will remain war.
Robotics, unmanned systems and drones will play a role. But I think it's fundamentally important to understand that in every war, no matter how high-tech it is, with fancy weapon systems, it will always, in the worst case, be the 18-year-old recruit who ends up fighting and dying in the mud somewhere.
All attempts to regulate autonomous weapons systems to date have failed. There are no agreements stating that machines must not be allowed to decide over life and death. No guidelines in the event that systems are hacked. It's up to governments and the manufacturers themselves to adhere to ethical principles.
This is what Europe stands for: values, ethical values, including in the context of war. And that is why it is very important that we should not lose sight of that, and that we should clearly address in NATO, in the EU, and also as the Federal Republic of Germany, which is not to say that such systems should ultimately not be used. I believe that they should and must be used, but of course, according to ethical principles, which are also appropriate for us, when used perhaps against other aggressors.
There are many questions surrounding the rise of autonomous weapons with artificial intelligence. One thing is certain: the wars and conflicts of tomorrow will be inconceivable without them.